Hello, my name is Dr. Russell Killingsworth. I am a veterinarian with an embryo transfer practice in Shamrock, Texas. I'd like to welcome you today to join us as we share how we are using real-time video data to determine embryo survival of cryopreservation. Cryopreservation of embryos has been instrumental in the growth of the embryo transfer industry. Cryopreservation, or freezing of embryos in cattle, began in 1973 when Wilmot's lab produced Frosty, the first calf born from a frozen embryo. Since that time, we've made improvements in equipment and medias and techniques which allow us to achieve pregnancy rates which are closer to those achieved with fresh transfers. The 2021 AETA statistics show that there were 232,000 frozen transfers. This represents 48% of the total of all embryo transfers. Cryopreservation allows us to store genetic material for use at a later date. It allows for more efficient utilization of our recipients. It helps us to manage our breeding strategies for desired calving dates, and it enables marketing and transport of genetics. There are two acceptable methods for freezing embryos. In the slow freeze method, the embryo is placed in a relatively low concentration of cryoprotective agent and then cooled slowly at half a degree C a minute to allow dehydration of the embryo before being plunged into liquid nitrogen. Vitrification is the solidification of a solution without ice crystal crystallization. A higher concentration of cryoprotective agent is used with a very rapid plunge into the nitrogen. Vitrification is more technically demanding during freezing and in thawing. Cells are composed primarily of water. We know that when water freezes and forms ice crystals, it expands. It's necessary to remove the water from the cells before freezing to prevent rupture of the cell membranes. Ethylene glycol is the cryoprotective agent used for the majority of embryos frozen today. Toxicity of the cryoprotective agents and cryo damage due to intracellular ice formation are two factors which lead to lower pregnancy rates with frozen embryos. Today, most embryos are frozen in ethylene glycol because these are the direct transfer embryos. Straws are removed from the storage tank, thawed in warm water, and then transferred into the recipients in a process very similar to thawing semen before artificial insemination. If glycerol is used as the cryoprotectant, it must be removed by a series of dilutions. Moving the embryos between these solutions must be done under the microscope. This requires extra handling, manipulation, time, and labor for this process. Because most embryos are direct transfer now, we seldom look at the embryo after it is thawed before it is transferred. The objective of our first study was to use graphic image processing and machine learning techniques to evaluate embryo health post-cryopreservation. In this study, we used donated in vivo derived embryos which had been frozen either in glycerol or in ethylene glycol. The embryos were thawed and rehydrated, and then a 30-second video was recorded. The embryos were incubated and then re-evaluated for development at 24 and 48 hours later. After incubation, we see that 76% of the embryos frozen in glycerol continued in development, and 70% of the embryos frozen in ethylene glycol continued to develop and improve at least one stage of development. In an attempt to measure the differences between these embryos, we use the graphic image processing technique of image subtraction. In this process, the computer compares each frame of the video to the previous frame. Any pixel change in the image from frame to frame is displayed as a white pixel, and the number of these changes is counted throughout the video. We calculate the mean pixel change as morphokinetic activity. In the results, we see the column on the left are the embryos frozen in glycerol, which continued to develop. The second column is embryos in glycerol, which failed to develop or stalled. We see a lower morphokinetic activity. The third column, embryos frozen in ethylene glycol, which continued to develop. And the last column are embryos frozen in ethylene glycol, which stalled. Overall, we see that the embryos frozen in glycerol had higher activity levels than those frozen in ethylene glycol. When we combine the glycerol and the ethylene glycol embryos, the results show that the embryos which advanced in development had a higher morphokinetic activity than the embryos which stalled and did not develop. It would certainly be valuable to know the viability of an embryo after it is thawed, but it could be even more beneficial if we could predict which embryos would have the higher probability of survival before we begin the freezing process. In our second study, videos of embryos were recorded after they were collected in standard IVD practice. The embryos were frozen, and then in the next 6 to 12 months, these embryos were transferred into recipients, and then pregnancy data was received. In this study, 95 embryos were thawed and transferred, resulting in 53 pregnancies. We performed image subtraction process again on the videos, and again, the embryos which resulted in pregnancies had higher morphokinetic activity than those embryos which did not result in pregnancy. As we gather more pregnancy data, we will continue to train the machine learning models to be able to identify which specific embryos have a high probability of surviving the freeze and developing a pregnancy. In our third study, 72 in vivo derived embryos were collected, 30-second videos were recorded. The embryos were then placed in 1.5 molar ethylene glycol solution prior to freezing. A second video was recorded while the embryos were in the ethylene glycol prior to the freezing. Image subtraction was run on all of the videos. In these graphs, the mean pixel change while the embryos were in holding media is represented by the dark blue peaks. The gray peaks represent the pixel count when this same embryo was in ethylene glycol solution. We can see in the top graph that some embryos behave very differently when they were in the two different solutions, while the bottom graph shows that some embryos had very similar activity levels in both the holding media and the ethylene glycol. Overall, embryos had lower morphokinetic activity in the ethylene glycol solution than in the holding media. This would seem reasonable if the changes that we are measuring are related to metabolic activity, because ethylene glycol may inhibit oxidative phosphorylation and respiration. We would expect these embryos to have lower activity levels. This final graph shows the number of embryos on the left and the percentage of change of activity, whether the activity was decreasing or increasing. These embryos are still frozen, but it's going to be interesting to see when we're able to transfer these and get pregnancy results, how those results compare to these measurements that we are seeing here. So if we look at key findings from today, post-thaw embryos which advance in development have higher morphokinetic activity than embryos which fail to develop. Pre-freeze embryos with higher morphokinetic activity establish more pregnancies than embryos with lower morphokinetic activity. Embryos frozen in glycerol have higher activity than embryos frozen in ethylene glycol. Analysis of embryos in the ethylene glycol solution may reveal critical indicators of successful cryopreservation. So overall, as we analyze these embryo morphokinetic activities, we're hoping to provide objective information to predict embryo survival of cryopreservation. Thank you. I would like to acknowledge my team, Cameron and Kara from mGenesis, for their hard work, their insight, and their creativity to help with this work. Dr. Joe Webb and Darren Dunlap from Vitality Robotics for the software engineering. Sydney Hickerson and Dr. Gibbons from the Texas Tech School of Veterinary Medicine for their work in the IVF lab, and to Michael Ray of Yellowstone Genetics for video and data recordings. Thank you all very much. Again, thank you for your attention today. Please contact me if you have any questions. Thank you.